Hey, what's up? How's it going? Just getting some readings on a coil on my pulse motor here. You get a sine wave and how much voltage is being generated by it. This is what is going on for the drive. We got a trigger coil right here, or a sense coil. Figured that out. Sense is the magnet. And then this coil right here is a series circuit 4-filer coil. It's got 22 gauge, 26 gauge, and 30 gauge in series. It's a 9-magnet rotor. See if we get any BMF off of that coil. BEMF, not bad. Here it is. These things are pretty good for getting that. It's 32 gauge coil, about 6,000 turns in it. Just need to get some clips that are gonna clip. Oh, and they're 4-filer coils, and I only mentioned 3 strands. This one, the 4th strand, has got this light hooked up to it. Alright, so let's hook up another light. Then I got a big light. Well, it's only a 30 watt. Maybe it's a 15 watt. I don't know. It's an LED black light. It works a little bit different than these LEDs. It's weird because I just saw it. It was, but you know what I'm saying? Can't make a smart goal out of it. It doesn't really count. Just hoping to get these connections right and see if it's really happening. I think if I had a core in there, we could get some BEMF action. That is a little far, I think, for not having a core. Maybe I could like turn it sideways or something. That would work better. Alright, let's see. Yeah, no, that's not gonna work. Alright, that's a bummer. But the induction electricity does work. So you get a nice big bright light off of that. But it has load. The good thing about BEMF is there's no load on the rotor. Oh, our meter turned off. Now I was using this transistor just a little bit ago. Something happened to it when I tried to hook up all 3 coils. So we're going to turn on the oscilloscope. Look at that. It's got like 12 peaks. Let me see if I can't just bring it over here a little bit. No, that's not going to work. I'm not taking that camera out of that thing though. I'm not. I shake way too much for the close-up. I wish my brother was here. He could get it real good for you. But you can kind of see it from where it is. Nah, not really. But it goes up and down like that, and it's equal on the bottom as it is on the top, so I'd say that's pretty clean. Getting 170 volts. Yeah. Each one of these transistors has a different threshold, you know? But as for resistors, I'm using this magnificent piece right here. It's a 100 watt, 200 ohm, 5% tolerance. So I think when these things stop working, it's because the base, the switching, it's not about how many times it switches, it's about how many times it switches in the condensed period of time. So yeah, it's going to switch a million times, but it switches a million times in 2 minutes instead of 8 minutes. It's probably going to break. Alright. So for those of you who don't know, we have the exterior trigger coil, or the sense coil, the one that senses when the magnet passes by. We have these 3 coils at 120 degrees, but this is the only coil that's hooked up currently. And it's hooked up in series. You only need 1 transistor to run this. It's a 4-filer coil with a 22 gauge, 26 gauge. Hey, what's up, my man? 30 gauge, all in a series. And then if you want to run a trigger inside the coil, there's an extra strand of 32, which is now currently running an LED light, because I'm using the exterior, which is a lot better. I mean, I finally figured that out, you know, that what was being talked about, you take it out and then you can move it around and get the timing right. I was like, I was shocked afterwards that I didn't understand what was being said. But now I got it, and you're right, it was awesome. So much more awesome than having it be off timing and inside, to have it slightly offset. And it doesn't need to be that much offset, just slightly offset. And it just doesn't stop increasing in speed. It doesn't stop. Everything has broken down so far. I mean, it gets up to, it's weird. it gets up to like a certain frequency, you know, a certain sound wave. There's no sound wave for the exterior coil though. It's just a kind of like a piece of glue or something that goes by every time. So I'm gonna put it on 15. I'm gonna give it a jump start. And the core is, this coil is extremely close for having a core. It's like within a centimeter air gap. It's very small. And the core is pure iron. So it's not like, it's iron filings, but those iron filings are pure iron. Oh, I'm getting there it goes. I don't know what that is though. It's really loud. Oh, I have one. I have a webcam. But, you know, it's got to be a wireless webcam that I can carry around with me. All right. So, yeah, I'm out of transistors actually. I'm working on a pile over there that is in the half and half. Yeah, the spam callers, man, that got my number somehow. So this is 15 volts, and it's a lot better than 15 would be inside this thing. You can see how, no, maybe you can't see it. Okay. Sweet. What does that mean? Is it both of them? The complementaries? Yeah. Yeah, you work with some pretty big stuff, but this one right here was like doing some magnificent stuff here. We had the multimeter here for the voltage up to like 240 for that one coil. So I'm not exactly sure if there was something wrong with it. I'm gonna try hooking it up one more time. All I gotta do is switch the wires here on the breadboard to the transistor. But you know what? I really like the squeaky noise that the thing made when the coils were inside the coils. Yeah, that resonant squeak for whatever it is, the frequency or whatever. Now we'll know right away whether this thing is blown or not. Because if it's blown, everything's going to attract and start bouncing around. If it's good, at least halfway good, it's going to not have an effect really until I spin it. You know what, I think we're going to be good. I do. 15, 16 volts, we'll do that, we'll start there. This thing is a beast. Yeah, that light's already not blinking. It's kind of funny. Anybody have an idea what that noise is? Then it levels out and smooths out and then it starts increasing with speed like dramatically. I'm gonna call this one Rocky Start. Nah, dude, man, I'm afraid it's this is my last transistor that's working. I don't think I want to put that much stress on it. But it sounds like the gears grinding in a car, to put it mildly. But then it levels out like it's doing right now. Ah, I see what you mean. But yeah, I can only spin it from the top. There's no like leverage to give it a good spin except from the top right here. It's the best spin. I've tried everything else. With your hand, I mean. Yeah, it is. Totally. We're at 144 volts right now, 145, 146. I'm telling you, it's a transistor. It's having the fast switching transistors makes all the difference. I think sometime in like afternoon, if you're available to do it in the afternoon, like around 6 or 7 is when I'm like unwinding and actually watching stuff. Even my own, like checking in with everybody who had something to say kind of thing. But the man we were talking to last night, Jake, was so right. This is way better, like way better than inside the coil. Even though I love that sound, it's like, you know, I love it. But I mean, this is better. And I can have this trigger coil out quite a ways. And it seems like the farther I get it to the fringe of all the action, the the faster this baby will go. Yeah, the sense coil. I totally understand now. I was like, oh, that's what he was talking about. And I kind of like, you know, because I didn't understand, I was getting frustrated. So, felt like a dummy after I got it. But yeah, straight up, this works better. And the ability to move the trigger or the Hall effect sense coil makes all the difference, like tremendous amount of difference. Now the only thing that kind of bugs me is that I've hooked all these up in a series on the same transistor, running it off of this trigger coil, which I should be able to do if they're timed right, essentially, correct? They're all hitting the magnet at the same time. We should only need one trigger. And it didn't work very well. So I guess even though it looks like it's dead on, there's a little bit more precise timing that needs to happen. And I mean, seriously, I'm moving this thing just a fraction of an inch, and it's like an inch and a quarter in like this type of thickness. So it's like an inch and a quarter wide. I'm moving it like a fraction of an inch, and it's like having a great deal of effect on the speed of the rotor. So I mean, like micro whatevers are definitely involved with that. I thought I could eyeball it, honestly. So what I think I'm going to do is I'm going to have the exact same transistor, and I'm going to have the exact same circuit with this one trigger. So it'll be more powerful, I'm hoping, than having it all on one transistor, have each coil have its own transistor, but all be timed by the same coil. And that was just like on low voltage for this, because it's a high voltage transistor as well. Like I think it goes up to 700 or 800 peak, and that's well within what I'm doing. So that's great. Oh, yeah, man. I really want to discuss this thing right here. This looks like, well, it says AC1, and then it's got a ground symbol, I guess, the electricity in a circle, the lightning bolt in a circle, and an AC2, right? So does that mean one end of the coil and the other end of the coil? The one and the two, is that like the in wire and the out wire for the coil? And then the voltage comes out rectified and filtered and scrubbed on the other side. Man, that thing is going fast. It's going fast. This is a lot of capacitors, man. I don't even know. Let's see if we can get a reading on the side here. No, it doesn't show. It does show it, but it doesn't like show it where I can see it. The capacitor size. Because that's, let's see here, 420 capacitors. And then it looks like we got these yellow boxes here on the side, and then we got LEDs on the other side. A part number, maybe online. It's got some bridge Yeah, this is a rectifier and a scrubber. So what I'm thinking is, yeah, I don't know the name of it offhand, but that's what I think that's what they call it. So yeah, like the name of this thing is 3 paragraphs long. So it's a 1200 watt, 100 volts, 12 amps. No, I think that it'll take either one. If there's no switch to change that. So I'm thinking if there's no switch to change it, that it's probably compatible with both. And it's not supposed to plug into the wall. You're not supposed to get the energy from the wall. It doesn't look that way to me anyway. Maybe you do. Maybe you do. You can. I know you could. But what I'm just wondering is if I use a coil, do I put one end in the AC1 and the other end in the AC2? I know what to do with the ground. You plug the ground into the negative side of the power distribution. And then I think this looks similar to what I saw on your live stream for the circuit to run the motor with the motor. Yeah, isn't that just like similar to what you were the thing you made? Isn't it like just like that? I mean, I think the principle is kind of similar. Oh, okay. Oh, yeah. Wow, man. So happy. Yes, that's the one. Yeah, man. I tried to remember that from my computer over here, and I totally lost all that on the way here. But yeah, that's the one. Oh, you're good. You're good. I mean, see, because if I can hook this thing up to this coil and then run the other motor like I want to do, but I wonder how it works because, yeah, I don't think it will work if there's a tremendous load from that. And there's no on-off switch for this thing, so I'm gonna have to build one in. Should I have it before or after the module? After, right? It doesn't matter, I don't think. And I didn't want to just plug and play this thing and mess around with it because it's, look at it, I mean, there's 20 capacitors in this thing, 4 rectifiers, looks like 2 trans, 4 transformers, something like that, and 2 LEDs. So I didn't want to just plug it in and have it not work anymore. This may very well happen. Oh yeah, and I can draw, like when we go over here to this coil, when we were getting all the readings from just a second ago, I hook this to it, and then I hook the other end out of it. It'll run anything in DC. Okay, thank you. Yeah, man, that's awesome. Thanks. So it'll speed up, is what you're saying? Or the second one, the second rotor. Uh, Yep, that's what I got. It's got 22,000 of 32 gauge for the power. Okay, so a range of 95. That's not bad. Oh, is that stable though? Is that stable at 7? It doesn't matter. It doesn't matter. That's good output though, I think. I don't think it's over unity. I mean that's what it looks like on paper, but that's not it. But that's awesome, man. Okay, so we were gonna see about the AC1 and AC2. Those seem like inputs. Um, so I just put one end of the coil into AC1 and the other end into AC2. Because if I can put two coils into this thing, that would be really awesome. But you said I need one. So I'm thinking because I only need one, I'm going to put one end in one side and one end in the other. And that's how I'm going to roll with it. I hope that's right. I have a feeling we're going to get more. I have a feeling we are going to get a little bit more than that. All right, so we're going to take out the light real quick. There's AC1. There's AC2. Here is the ground. It's amazing how quickly these things just get snarled into just unwindable stuff. All right, let's see. Haha. Oh yeah. That's good, man. If you want one, that means it must be good. I mean, seriously, that stuff you do with the single file, or no, the bifilar coil, and it's the coil's in the coil and it's working like 3,000, 4,000 working. That's awesome. Oh, nice. You got a new rotor. Sweet. Sweet, man. Oh, yeah. All right. So, all right. You guys get to watch me do something. We're going to transfer some wires to the butt end of this. I can't believe it, man. There's like 20 capacitors for this thing. And they look like they're 10-volt capacitors. Don't ground the coil. What do you mean don't ground the coil? I have the coils plugged into AC1 and AC2. So one end goes into the lightning bolt side and the other end goes into AC1 or AC2. Okay. Does it matter which one? Doesn't matter which one, they're the same? Okay. You don't want to ground it, so we'll do this. We'll take this out. Good looking out, man. Good looking out. And we'll switch the AC2 to the ground. Right? So, okay. And this is what we call a pickup coil. This big coil right here is a pickup coil, okay? Because it's picking up electricity as the magnets move along. Gotcha. All right. So here, let's get this part of it done real fast. And this little thing that I'm taking the wires out of is a little mean transformer. Kind of looks like a microwave transformer if you think about it, just miniaturized. Oh my Lord. There it is. There it is. Got it. Wow, that looks like it's on. Those look like they're on. Whoa. Yeah, the LEDs are lighting up. So what about the other side? How do we hook the other side up? We got the OV, negative V, and plus V. Right now we're seeing if we can't run a pulse motor with a pulse motor. I'll explain what this is if you want to know in just a second. It's a pulse motor with one drive coil and one sense coil. for, you know, like a Hall effect for a sensor, a magnetic sensor. We're using a coil for that. And then we have a pickup coil right here, which is rather large, and we're seeing if we can't rectify all that stuff and run another pulse motor with the energy that comes out of the other side of this. So technically, we could put one in AC1 and one in AC2 and have them both have the other wire connected to the lightning bolt. Yeah, but it doesn't output voltage. Can't you just get both of them in one wire then and use output voltage? I mean, you got negative V output voltage and positive V, positive voltage. But which ones? Negative and positive? And just leave the middle one alone for now? Okay. Let's see what we get. So positive and negative. And then that one goes to the brown. And this one goes to the ground. Brown to ground. Awesome. All right. I'm going to start with that off. Okay, we're going to see if this thing works. Oh, I forgot to put the on-off switch in there. It's really close. Really close. All right, our lights are on. That's neat. That's neat. He's going through the scrubber and the filter and everything. No load on the rotor, really. Don't know what's happening there. Well, that's really bright for how much is actually happening here. Now let's give it a second. See what the load really actually is on that. Oh, I unplugged it all. So I can plug that in. It's alright. Breakthrough. Oh. There it goes. Alright, now it's going. How much is being boosted? Alright, let's get a look at it. Alright, I'm gonna just try and get this whole thing over here real quick. There we go. Alright, wow, that's really bright. That's almost as bright as plugging it into a socket. And it's stable. It's stable. It's really stable. So 71. 71 volts. And it's stable, kind of up and down right now at 72.4. Hell yeah, dude. I saw the 20 capacitors lined up in like synchronicity order, and I was like, that's got to be powerful. I have no idea what I just said, by the way. The order, man, it's great. Both lights are on. Yeah, that is, man. I've had it for a while. I never knew how to use it. See, I would have plugged both ends of the coil into the AC 1 and 2, and it would never would have worked. And I've been like, oh, it doesn't work. I might as well send it back. But I'm glad we had this live stream, man. I figured that out, and I think I can run the second pulse motor with that. Heck yeah. Thank you. Yeah, one thing that did discourage me about what I've been trying to do and what was not a success is this coil in a coil. It's like a mini transformer, right? It's got 3,333 turns of 32 gauge in the middle, and then it's got like 725 turns of 20 on the outside. Now, when you put the energy, send the AC through the center one, you should be able to get a reading off of the secondary coil. Am I right? Why though? Oh, this coil or all the coils? Oh yeah, I mean, it was just the idea of like having a transformer. I know how they work. You got the thinner wire in the center, and it didn't work anyway. So I mean, like, wow, it's got to be something. Maybe uniformity is the answer. You know, it's got to be like you made yours very uniform. Yeah. Well, I stumbled onto all that crap on accident. Honestly, I was just. I think it was the first time I actually got a transistor to work. And I was like, wow, this thing is moving this thing pretty quickly. It's just 50 turns. And I started making coils that would have bobbins that would, when you wrap the coil, it would hit the exact edge of the magnet that you're using. Let me get the green paper real quick. All right. Well, that actually looks like it might be getting some BEMF off of the trigger coil. I might as well not use the one that's moving. We'll use this one. All right, you see that light, that bright area around the magnet? That's dark. See, the magnet's dark, but the area around it is really bright. I designed the coil for these magnets that would hit in that light area perfectly. And so you didn't need anything because the amount of efficiency from position, like you said earlier. Oh yeah. So that light ring that's around the edge of the magnet is where I made the coil, the bobbin. So you wrap the wire around it and it would hit like right in that area. That little tiny area. and leave everything else alone. It would just not utilize the other parts, just the most active parts of the magnet, which of course are not even on the magnet, they're slightly off the magnet, like as you could see there. And then like the magnetic field itself, I have a bunch of iron filings. Because this green paper does not show what the filings will show. So, yeah, and you want to see the second design. I'll show you the second one real quick. This is what I got done of it so far. I've got another, but this is the best one yet. That's levitating. I need to clean the pole because these bearings are a lot better than that. Anyway. And then I'm letting the magnets dry for the first two rotors. I've already got the bearings in those. I'll show you those two real quick. Got 4 magnets on the outside that repel the rotor in the center, so they'll spin hopefully. Hello, how's it going, Seven Crows? What's going on, man? That name sounds prophetic. It really does. Seven Crows reminds me of Brandon Lee's movie, The Crow. I don't know why. Maybe it's just the name. Anyway, I think that's really cool, man. Welcome. Oh, you left? Please don't leave. Yeah, I don't know. A lot of people can't handle this. A lot of people can. Anyway, for those of you that can hang, man, you're welcome to stay. Those of you that can't, you're welcome to stay too. There it is. So I'm going to show you the bobbins that I have made up, or that I've got for, I think Peter has seen them before. But I think I'm going to wrap some 36 gauge in these little bad boys right here. Add mercury. What, for inertia? Yeah, these little bad boys are gonna make that little pulse motor move. Spin it. So, now I'm thinking Beastie Boys. Oh, this? And that's the cool thing about this is if I can suspend it from the ceiling, the outer part will spin as well. So everything on the inside and on the poles will be spinning their directions, and then the whole thing will spin. And wow, man, it's gonna be great. I just need a magnet strong enough to hold all that when it's all done. Yeah, if they made latex gloves or, protective wear that was big enough to fit me, I might play around with some mercury. Right, because it's metal. You telling me that it has eddy currents? I have one. I have one. Yeah, I know. I got a pump, I got a chamber. Um, I can get those out. I haven't seen a need to use them, but I can definitely get those out. So it uses the ground to lift off of, or does it? What does it do? I mean, in my understanding, in order to achieve lift, you have to have something to lift off of. Well, I understand lift. I understand how you achieve lift to a certain extent, and this isn't it. But has anybody seen one of these work? I would love to have one of those in my house, and I'm only going to spend money on that if it works. I want confirmation. Sounds really awesome. And when I say confirmation, I don't mean some half-eaten newspaper that was printed 50 years ago. I'm talking about like today. If one of you guys have seen this work, I will I will make it happen. Yeah, I could see how the metal would help that function better. I mean, it functioned really well. It just was made out of the wrong material. Because the thing is that when it would get fast, like towards its, he doesn't even know what its top speed really was because it would always melt. the hydro turbine. No. I mean, I bought store-bought things and all that stuff, and that's great. I love the levitation, the electromagnetic levitation. That's awesome. But this mercury thing, I really, and not like a Baccarat's wheel kind of thing, but like a real, it lifts up off the ground due to, anti-gravity, eddy currents, and whatever else, other forces you need to make that happen. I think it's awesome though, man. I really want to see that. Nice. I'll have to check those out. Let me, but I mean, how much money are we talking there? And can I build one myself? Yeah, that's what I want, like a tabletop toy that I can mess around with. I think this is great, man. This thing is running so smooth. And that light is getting brighter and brighter. Let's see. Yeah, that's amazing. Ah, yeah, Mercury is perfect for off balance kind of things. Because of its the 71. Yeah, you're right. It might burn out. Just turn it off. In that little one, because this one already has a core. Yeah, without that light on, we're at 101 volts coming out of that thing. 102 volts coming out. Oh no, it didn't burn out. got an on-off toggle switch. Yeah, man, when I let it run, it goes up into the hundreds of volts. I got something else that might be interesting, maybe. Got a lathe motor here, 3,500 RPMs. Yeah, I don't know if I should be messing with this thing with, right, but I'm not gonna hook it up while it's on, dude. I'm not gonna do that. Even though I might be 100%, like 98% okay, then I'll be fine. I'm just not gonna trust. That's 100 DC volts. I'm not messing with that. That's 20 capacitors right there. I'm just not gonna mess with it. But I'll swap them out real quick and we'll see what's up. Oh yeah, dude, it's like lit. Because it's caps. Yeah, alright. But, oh no. It's just gonna have a desired effect. Get off of me. Get off of me. I say no. Okay. That was what I was talking about. I guess I needed to, what do you call it? Clear the capacitors before I touched it. I should be using a speed knob with this bad boy too. I don't have one readily available though. Alright. What I had was 2 toroid magnets hooked up here. And they were turning like 10 smaller generators. So I had the big toroid magnet in the middle here and I was spinning it and it would grip all the little ones surrounding it and it all generate electricity. And the big one in the middle would generate electricity. So I mean, everything was generating electricity. Yeah, man, the mercury is a magnificent metal. And for an off-balance system, I think it's like essential almost. All right, so let's clamp this. Oh man, see, I don't want to just leave it here because as soon as it kicks on, I think it's going to start going. This is a 12-volt motor though. I know what I gotta do. This is it right here. I'll put a toggle switch on that. I'll feel better about the whole thing then. All right, I think this is gonna work. If I can get that motor to run, man, we're gonna take off from there. Oh, the motor might be broken. I can feel it jerking in there though. No, it's not broken. Maybe it is. Maybe it is. All right, here we go. Man, these things are stiff. I gotta put this down. I gotta hold it still. Oh man, this is so. Well, we had something. Oh, the lights are out. No, it's not. Well, I mean, yeah, it's spinning. It did spin for a second. Probably way too many volts for this thing. Oh, I got an idea. Maybe we gotta ground the motor instead of hooking it back up into the, I don't know. So just like the one on the outside there, I'm going to take this one. And put it in the middle. I think that'll work. I don't know. I have a good feeling about it, kind of. So this is split down the middle. There's 10 capacitors for, it's really weird. It's going to be there today. A lab coat. Yeah, I can't get it to run sustainably, but it spins. It does move. All right, heck yeah. We need one stick of bubble gum and one neodymium magnet, and we can save the world. That's right. You got to have some kind of adhesive. You know, you got to be able to put that magnet wherever you need it. So you need that stick of gum so you can put it on like plastic or something that it doesn't stick to naturally. So what happens when I turn the switch off, all these capacitors fill up. And the light turns on, gets really bright. All right. And then when I turn the switch to the on position, I don't know if you can see this. I'll put it up here. I don't know if you can see it. Not real well, anyway. All right, and then so it jumps around, jump around, jump around. But as soon as those capacitors are unloaded, they don't load back up. As soon as you turn that switch, that light goes off. So that, I don't know. But that's with that. Oh, that might not even be right. Oh yeah, definitely that would probably work, but the rotor doesn't really spin well, and I'm thinking that it'll be fine if I'm just running a coil. This is like a pre-built motor. Thought it would run nice, but it doesn't. Yeah, you're right. Let's see what else I got up here. Nothing. I mean, I got my wind turbine, or my, definitely hook a wind up to this beast. See, when I hook the rotor to the shaft, I can put this on there like that. And then it'll spin it. But yeah, that's an experiment for another day. Let's see here. So as I was explaining earlier, that big motor that I was trying to get spin, I had big toroid magnets hooked up to it. These ones. And then these were hooked to smaller generators, and they would, the magnetic, it would just, and they could spin really fast too. Like that one goes 3,500 RPMs. And then you could pull from all of those generators electricity. But my table is not hooked up to do that at the moment, so I'm not gonna bother with it. Just food for thought. All right, so yeah, and when you plug it into both sides, it definitely cancels out what's going on for either side. Yeah, I'm gonna put some of this away because I'm not using it. I'm not gonna use it right now. All right, so we're gonna get it going one more time. So it's about 70 volts, this thing. And I'm sure that it'll be good enough electricity to run a coil and a switch of some kind. have not seen a lot of in this coil variation is BEMF. I have not seen a lot of that in any regards. I mean, even if there's not a core, there should be some. There should be some. The light should at least turn on a little bit. I'm thinking it might be my connections. I don't know what it is, honestly. But I think it goes extremely fast for not having any of that going on. Can't wait till the other transistors get here. Sounds like it dies after that point. Thank you, Seven Crows. I appreciate you coming through. But once it gets over that hump, it's really quiet, nice, smooth. It's running great. But it has that little hump that it's got to get over. I don't even know what that is. Probably has something to do with the core in this coil right here. This is the only thing really putting a load on the rotor at the moment. Oh man. Now if I put a core in this trigger coil, I could probably run a MOSFET without trouble. Because then we'll be generating in between 5 and 6 volts every turn. And I just think it'll work out great. Right now I think it's a little low for running a MOSFET. But having this, the trigger coil be able to be moved around, or the sensor coil, actually makes more sense. I can back it out, and if I see that as I back it out, the RPMs increase up to like the fringe, where the magnet like brushes the coil. It's awesome how like just micro changes help with everything, or hurt. Can hurt it just as easily. Usually I find myself putting it exactly where it needs to be on the first go. I get it right. And then I always think, oh, maybe I should adjust it. Maybe I should adjust it, and then I lose it. And it just either stops altogether, or it just slows down, or just something catastrophe happens. But I mean, right now there's about 2 inches, or 1 3/4 inches distance between the trigger coil and the rotor. Now you can't get that with dinky ass magnets. You can't get that reach that'll work with weak magnets. You gotta have strong magnets. So I think this is good. This is 21 volts, and these are high frequency, high voltage. Sure enough, 26. Now I got this coil to generate 250 volts of AC electricity on its own. And then when we shoot it through that thing I was just playing with, I put it over there. That's awesome. I've never got that thing to move as much as it did with the pulse motor. Oh yeah, the sweet spot. I think I found the sweet spot for that coil. Now these two need to be adjusted by a couple millimeters even to be as function, to add to function. Because right now they hinder. Whenever I hook them up, well, I hooked them up in series to the same transistor, and it made it worse. And when I say them, I mean the coils that are at 120 degrees. And I'm sorry you can't see it, but I shake. And if I hold the camera, it's going to be terrible. But these are at 120 degrees, or they looked like they were at 120 degrees. I'm going to have to move them around so that they actually are right. Might just be the distance, but position is key. That's so true. But this is one coil, and I'm assuming that the more copper you add in regards to drive, and this is the opposite of what I found to be true, the faster it'll go. I think that in order for that to be true, there's a lot more that goes into it than just, a coil, a switch, a transistor. There's more that goes into it. There's a lot more that goes into it. And I learned about this over time. You got your resistors. This is a badass resistor. Okay, this is not normally what you would find on Amazon when you type in resistor. It's not what it looks like. This is closer to what you would normally find. These are 5% tolerance resistors. And for what I'm doing, it's essential to have something at least that strong. All right, so you got your resistors, you got your diodes. This is a rectifier diode. So it turns AC into DC. I learned about those. And then, all the different transistors is enough to blow your frickin' mind. What are you talking about? I don't know what that word means. But this is a 100 watt, 200 ohm, 5% tolerance resistor. And it's taking care of my transistors like they're babies. No, I know, I understand which one you were talking about. I just don't get what the word means. Right. Is that like some sort of slang? Because I've heard like just it's reminiscent of so it's not slang. It's like an actual term. Well, that's pretty disgusting. Oh man, I don't know. You know what word comes into my mind when I see that? The wild hunt. It's actually a phrase, and it comes from the Witcher games. Well, it works really well where I have it. I still think that's like, it's a distracting word to call a resistor. Just my personal opinion. But I guess, oh, I got more diodes over here that are different. And I got some capacitors that I really like to use. These here are 2200 micro and 10 volt capacitors. They're my little babies. And these here are some Shotskys. Oh, come on. They're like fat rectifiers. Well, this isn't a high current application. And it's working better than anything that I've used thusly. Oh, my bad. I don't mean to suggest that I know what high current is. I just learned the other day that high voltage starts at 5 volts. So, yeah, it could be definitely high current application. While that little baby is whipping, holy cow. Yeah, man, there's so much, like, you feel more secure with the bigger resistors. Because I got all the way up to like 1,000 ohms, 10,000 ohms of, with the, like the 0.5% tolerance and the 1% tolerance, they would instantly fry. Instantly, like catch on fire. That's good. That's good. Thanks, Double O. What's up, man? Yeah, the potentiometers. All right. Well, I don't really have anything else that's going on right now. It's getting hot. I think I'm going to turn on the air for a moment. Look at that thing whip, man. I mean, it's got 30 volts going into it, but that is fast. Yeah, that external trigger coil really helps with the noise. But I like the noise a little bit. Heck yeah. So I got these little transistors in the mail right here. These are, I think they're E13009-2s. They don't work very well. They say they're high voltage, good switching, fast switching, and they're lackluster. Quarter-inch holes for quarter-inch poles, man. Unless you're like King Kong and you grab the lady, you're looking at the lady and she's like, oh my God, and you're like, I'm gonna make it fit. I'm gonna make it fit. Man, it's hot, man, I'm sweating. That's what she said. Well, if you can give me $200, I'll find that out for you. 00. I was really curious myself. The only problem is the clear Gorilla Glue that I use to glue in most of my magnets isn't going to let the magnets go very easily. Huh. But yeah, I've been dying to see what that would be like, because that's like double the field. That would be awesome, I think. Like really badass. Because honestly, you get more south in there if you put another magnet on. Now, I do have 3, maybe 4. I would stop at 3 though, that I could put on there. They're busted up though. Let me show you what we're working with. Well, yeah, there's a reason why I haven't used these. Only one of these is usable. The other one, this is glued, Gorilla glued onto a 100-pounder. Wow. Oh! Oh! Yes! That's one. Alright, let's see here. Now it looks here like I can get one, maybe two off of this, and then we can have three that we could add on there as 120 degrees, and that would make sense. I got the perfect thing. Wow. Just gonna clamp this down to the table. Oh man, that probably won't work. Yeah. Yeah, these they're not gonna work. Huh. Oh. I know what will work though, but I'm not gonna do it right now. If I cannibalize the only rotor that has the magnets not glued in. But they'll be square. Be square on that, so I don't know. Maybe I'll just get some new ones, and I'll only do 3 of them. So you gotta understand that if I put them on there, I'm never getting them off of there. Probably not. So I might actually try it with a different one. All right. So that leaves me with a lot to think about. Like if I were to put like a magnet on top of this magnet right here, how would that interact with everything? I think it would make it better, like stronger, more electricity. What about you? What do you think? All right. Well, I think that's going to be it for right now. From what I understand about magnets, the actual fields, I don't even know. Some people say that the field becomes stronger, and some people say that and the reach increases. Not just stronger, but the reach, the distance it goes is more when you stack them together. But I think the reach does not increase, actually. I think the reach stacks physically. So like if north and south, the magnetic field, I don't even know. Because I know that some of my levitation experiments that I did early on physically showed, like some of my levitation, that when you did a north-north disc, like north magnets on both sides, that it would levitate lower than a magnet with a north-south. And when I say magnet, I mean one of those discs that I make. It's just a big magnet, basically. So if you do all north on this side and then all north facing on this side, it will be a weaker north for both sides than if you were to just do north-south. So I think it stacks like that. Like if you don't take advantage of the north-south polarity, I forgot exactly how to explain it, but I think when you touch the two magnets together, they don't really combine in that way. They stack on top of each other like two. Anyway. Yeah, I think that the strength itself is what does not increase. The field gets bigger. The strength, if it's N52, it's going to be N52 no matter how many you stack together. But yeah, I think that'll be sweet. I think it'll be dope. Because like every time one of those extra magnets crosses the path of the trigger coil, well, no, that won't work, will it? Maybe we gotta get it. Maybe we gotta get it for every magnet for it to make sense. I don't know. I don't know. But I do think that everything will be close enough for the ones that don't have the extra magnet to function. If you get what I mean. Everything will work still, but it will just work stronger when the extra magnet comes across. So in that aspect, it will be really uneven. Just my hypothesis that that's going to end up being a really uneven build if I just do 3 of them. But I need to see how far along these little rotors are coming so that I can see if they're even going to fit on the sculpture base at all, if they have a place or not. Hello, hello. So basically, what this disc is, it's just a big toroid magnet. Not really, but it is. Small toroid magnet, regular sized toroid magnet. Perfect. So what I use to center those magnets on the rotors. Hello, hello. Yeah, I wonder if I could actually do that now. Probably not. I should probably wait till tomorrow to mess around with those rotors. And then I'll put the rest of the poles in. And then I got to get the rest of the bearings. I just was seeing if those work. These work really nice. They're needle tooth bearings. So you're saying I should wind that little bobbin up that I showed you with 38 gauge? That makes sense? For the pickup coil for the second pulse motor. This little thing right here. Because the second pulse motor is actually going to be the rotor for my sculpture. This is it right here. So I want to use the big one to move the small one, but the small one's going to have the biggest load on it. I mean, even if we only go up to the top of the small poles, it's going to be like at least 2 full layers of rotors that's going to be spinning. When I say full layers, that means the rotors go all the way around to the opposite side. Yeah, but that thing that, you know, with that thing we were just playing with earlier, plug it into this and get a reed switch, one of those little baby reed switches, because we're going to fit it all on this. The whole system is going to be on this. Will it run though? With zero current being drawn. All right. Yeah, then we're good. I mean, there's no guarantee it's gonna work right. I mean, anything could happen with wire that small. You could rub it against your pant leg and the enamel will come off. So, I mean, anything could happen. But yeah, I mean, if I can finally get that part of this to happen, that would be a big step forward. But I mean, isn't the 71 volts going to be too much for it? Of DC electricity? Yeah, you're telling me you wound that entire piece of PCV with 38 gauge? That is sick, dude. That uniformity was immaculate, dude. And you're talking 38 gauge. Let me put that up to the camera again real quick. Oh, that's not 38 gauge? That's 30 gauge, or 32 gauge, right? Yeah, the big red one. What is that? That's 28? Okay. All right. Yeah. So 32, 38 should be good for that little coil. My bad, dude. I thought you run that in 38 gauge. All right, I think my battery is actually starting to run out on my phone real fast here. Let me plug it in. Smaller gold one is like 36 gauge. I haven't seen a smaller one. Yeah, it's not gonna happen. It's not gonna happen. I thought I could, but I'll have to. Okay. Yeah. You mean on your table? Do you use it? I might have missed it. If you were using it. Oh yeah, I did see that. I did see that. Heck yeah. No. I was there. I was there. Yeah, I totally saw that one. That's cool. And what was that? Like solid copper? It looked like solid copper, but it's not. It's 36 gauge. Yeah, that's awesome, dude. But what I want to have happen, and I don't think it's ever going to happen, is to add these two coils in and actually have it increase in torque and speed. So far, my hypothesis is that the more I add to this thing, the slower it's going to get. Oh yeah, and you gotta have like the patience to tape it at the right time. And like I gotta go to the John or something, and you gotta tape it. But you gotta have the right tape. You know, if your tape is too strong, like duct tape, you might end up ripping your coil. But 38, I don't know. Done a lot of stuff with 38. I made some trigger coils with 38. But yeah, thank you very much, ladies and gentlemen. Peter, for swinging by, and I hope to see you again sooner than later. All right. Have a good day, people. Thank you, and I'll be around Yeah, that's what I'll be looking for you. All right. And maybe my cameraman will be available later before 7. I don't know though. All right, thank you. Bye now.